how we might build a modern distributed cloud-native web application today. What logic goes where? What's the UI anymore? Is it a browser or is it something else? How is what can be run in the browser changing today given some of the new architectures and technologies available? And what is this thing called the application edge? WebAssembly or WASM is one of the technologies challenging how we think of browsers and the edge today. It's enabling us to run real workloads in interesting places in new and innovative ways. Hello, my name is Wes Rice and I'm your host. Today on the podcast, we're talking to Ashley Williams about WebAssembly. Ashley works for Cloudflare. Before that, she worked on the Rust programming language and WebAssembly for Mozilla. Before that, she worked for NPM. She is a member of the Rust and Rust WASM core teams. Today, we're talking about what WebAssembly is, what the challenges are, where it is today, what's being done, what's the developer experience, at least with Bootstrapping, something with the Rust toolset today. We'll talk about Wasi, or the WebAssembly System Interface. It's an initiative to run WebAssembly on all devices, computers, and operating systems. We'll talk about this application edge that I mentioned and the use cases that are being run there and the push to run real application logic at the edge. And then finally, we'll wrap up with a bit of the roadmap for WebAssembly in the near term. As always, thank you for joining us on the podcast, and thank you for joining us on your jogs, walks, and commutes. Ashley, welcome to the InfoQ podcast.
Hey, Wes. It's great to be here. How's it going?
It's going great. So I wanted to do a podcast about WASM, about WebAssembly. You were the first person that I thought about because you've done all these great, amazing talks and been so awesome at QCon, so thank you for that.
Yeah, of course. It's been great. WebAssembly is brand freaking new, so not as many people jumping in on it, but I'm excited to get everyone into it.
Yeah. There's a few questions that we hit on every time, someone brings up WebAssembly or WASM. They usually are around what is it? Is it the killer for JavaScript? And why do we need it? Something along those lines. So let's jump in. When we talk about WASM, I think of it as and let's see if my definition jives with what you'll say, but I think of it as a language, a higher level language, or a set of instructions maybe that is a compilation target from other languages that are high level languages like Rust or like C++. I think C# has a bridge. I think that's the right term.
Yep. C# thing is called Blazor.
Blazor, right. And it runs within a browser, at least traditionally, but we'll get into a bit more about that later. Is that an accurate definition?
Yeah, I think so. I mean, that totally flies. I often get a lot of people asking me in cars or elevators, like, what do you work on? And I say WebAssembly, and they go, what? And so it's a little bit of a misnomer to call it WebAssembly because people love to say it's neither web nor assembly because it's not. You're totally right. It's a set of instructions. It's a low-level byte code target, which means that you can write WebAssembly from scratch, but you probably don't want to. It's something that you're going to be targeting from another language. And it exists, and we kind of added it to the browser because it's this portion of the web platform that we've been missing for a little while. JavaScript is awesome, but JavaScript was originally invented to create like small little interactions in a website. And now today we're using JavaScript to write full-fledged applications. And like a lot of people say, hey, JavaScript was never designed to do that. And I feel like JavaScript is plagued by it was never designed to do that, and certainly was never designed to write like super high performant applications. And we love the web platform because it's open, and so this new kind of lower level area of computation that we're going to be able to do in the browser now allows us to open this great platform to all types of applications that were previously excluded, like games. Or Google has this great demo where they compiled AutoCAD to WebAssembly and ran it in a browser.
What's the use case? What's the secret sauce? Is it for highly performant bits? Is it for like graphically intense things? Is it for like multi-threads? What do you use WASM for that has been poorly used for JavaScript today?
The first thing I will say is not that many people are using WASM right now.
Right.
As I iterate a bunch of things, a lot of these things are what I would imagine use cases for WebAssembly would be.
Gotcha.
So just because you mentioned the threading bit, WebAssembly does not yet have threads, but there's stuff that we're working on. The thing to know is like WebAssembly was born in 2017, which if I check my watch, that wasn't that long ago, right? It's still a baby, and what exists in the browsers currently today is not the final step. It's really just the beginning. It's growing like all web technologies do. Think of what JavaScript was on its first day.
Fair enough.
The dream of WebAssembly kind of falls along two lines. The first one is the one you kind of talked about, which is this idea of performance. It is a lower level bytecode, so it's going to be smaller to download. If you're looking at stuff over the network, moving something smaller, that's going to make it faster. Talking about whether or not it is more performant is currently a little complicated. For tasks that it is well suited to, it is incredibly performant, but it's not suited for every task. And a lot of that task comes with how much you have to go back and forth with your WebAssembly talking to JavaScript.
Okay, fair enough. What are the tasks that it performs really well?
I would say that WebAssembly is like super well tasked for, a lot of number crunching. So you want to maybe rotate an image. You want to maybe throw some sort of like TensorFlow type thing in the browser. Just really high processing tasks where you can kind of have a set of data, hand it over to the WebAssembly, have the WebAssembly crunch it, and then have it send it back. If alternatively you have an application where you're kind of constantly sending stuff back and forth to WebAssembly, we often call this the trampoline, can be really not performant. Like in all types of programming, crossing certain boundaries has a large cost to it. And so you're going to want to avoid crossing those boundaries if you want to actually take advantage of WebAssembly's performance.
So things that are highly computational intensive that you want to be able to churn on, crunch on, and then when you're done, be able to hand back. That's a good use case for WebAssembly.
Yeah, absolutely. And I mean, all of these performance things are going to continue to improve and get better. One thing I do want to mention that I think a lot of people don't entirely realize is kind of like this like sleeper awesome quality of WebAssembly. So if anyone's been doing JavaScript for a while and you're doing it in the browser and you want to do performance, you may share this sentiment that the garbage collector is your worst enemy. And this is not to denigrate JavaScript in any way or garbage collection. Like these are things that can add tons of benefits. Things are always trade offs, right? But WebAssembly doesn't have that. And as a result, like again, the performance, you're likely to see performance improvements with WebAssembly, but what you will definitely see is performance consistency or predictability. It is significantly easier to predict WebAssembly's performance than something like JavaScript because of that lack of garbage collection, that lack of runtime.
Very nice, very nice. You mentioned the demo that they talked about at Google I/O earlier this year with WASM and AutoCAD running in the browser. That was a cool use case because it was like a 20, 25-year-old code base written in C++ that they actually ported to run into the browser. What are some of the other big wins that WASM has demos or use cases of late?
Yeah, well, I'm so glad that you brought that up because, as I had said previously, these arguments for WebAssembly's use case fall along two lines. And so this first one was like speed up the hot paths of your JavaScript. The second one is don't write JavaScript, write something else. And because WebAssembly is this compilation target, assuming you can get whatever language you want to compile to WebAssembly, then you can write your program in the language you want to write it in. So that could be, playing into there's a huge crowd of folks out there that are amped for WebAssembly to kill JavaScript. And I'm not part of that crew, but that crew exists. But the softer way to kind of talk about this is there are package ecosystems out there in C, in C++, in Rust that have really awesome utilities. And you see people in JavaScript ecosystems wanting to use them. If you've ever been a Node developer, you may know the term native dependency. There's tons of packages out there that have these native dependencies, and that's because that Node package is probably talking to some C++. But those native dependencies have really not been accessible to people who want to be running stuff in the browser. And WebAssembly changes that. It says, hey, okay, you have some C++, you really want this. Maybe, I think Unity and some game developer studios have tons of awesome C++ code, and they can run that natively, and that's great, but getting it in the browser is really tough. But you say, hey, I can compile that to WebAssembly. Now you can leverage the ecosystems of many other languages inside the browser as well. And so instead of seeing it as a let's get rid of JavaScript, it's more of a widening of, okay, you don't know JavaScript, but you know this, like, welcome, you're on the web too.
I like that. That's a great tagline. Welcome, you're on the web. Can you walk me through what it might look like to bootstrap a WebAssembly application, say maybe using Rust?
Yeah, absolutely. So the way you would do it in Rust today, we've built out a ton of developer tools. I spent all of last year doing this with a bunch of really awesome people, in particular Nick Fitzgerald and Alex Crichton. But you will pull down a template. We've built out a template for you, and you build out a small Rust library. You could say, hello world, and you export a function. So in your Rust, you're going to have to note on top of that Rust function, we use an attribute and say, hey, I want to be able to access this from JavaScript. Then you're going to run this tool wasm-pack, which I started building last year and continue to maintain. We released version 0.8 yesterday. Pretty cool. You're going to run that, and that is going to do a whole bunch of stuff for you. The first thing it's going to do is compile your Rust into WebAssembly. The next thing it's going to do is it's going to run a tool called wasm-bindgen. And if you are like me 2 years ago and think Bindgen sounds like a weird city in Germany, you're not wrong. But what that does is it does what we call generate bindings. And the reason you have to do this is because the number of types that WebAssembly can understand is very, very small. And if you want to put your nerd glasses on and say, well, yes, I can express any program as a number, that's great for you, but it's really unpleasant for developer experience.
Yeah.
And so even like who thought I would be on a podcast saying that JavaScript has a wide array of like a rich type system, but it certainly has a richer type system than WebAssembly. So here I am. We'll see. The internet will come for me for that one, I'm sure. But so you want to be able to talk to your WebAssembly with JavaScript the way JavaScript wants to talk, with like objects, classes, arrays, all of that. And so this wasm-bindgen step is going to generate JavaScript boilerplate that's going to wrap all of that stuff for you. And then finally, so we output this JavaScript for you, we output this WebAssembly. We also do all the boilerplate of instantiating your WebAssembly for you, so you don't have to worry about that. It can be a little bit weird. How WebAssembly is loaded up in the browser right now can be a tripping point for some folks, but we like to just generate that for you. We load that up, and then it's almost as if you're using an npm package. You can talk to it as if it were written in JavaScript. And that's a really interesting thing about WebAssembly is like at the end of the day, it's an incredibly low level technology and it will be successful when everyone is using it and no one knows.
Nice. So it's literally just calling a function.
Yep.
Very nice.
We're doing a lot under the hood there for you.
Oh, I know. I remember right after that Google I/O, right after that WASM talk, I took the tool chain that they used for the talk and just to kind of play around with it, we kind of worked with a Hello World, some things like that. And I remember a frustration or two.
Yeah, so I believe, and I might be wrong here, but I believe that the toolchain that was being used for that demo is a toolchain called mscripton.
Yep, that sounds right.
Which is super worth shouting out because mscripton was like the proof of concept that made like everyone be like, okay, WebAssembly is a thing now. You used to produce wasm.js, which if you really want a fun dive into JavaScript syntax and performance hack, there's some very interesting ones in there.
Real quick, since you bring it up, wasm.js was an important stop or important part of the journey towards WebAssembly, so we should talk a bit about it. What was wasm.js?
Yeah, wasm.js was a subset of JavaScript that could be super optimized. That was like the big thing was like we can take this subset of JavaScript and know that like browsers are going to really be able to optimize for this. So it wasn't like a bytecode, it wasn't like a different thing. It was just like I really want this JavaScript to be able to go fast, so I'm willing to like do a ton of hacks and use just a small amount of JavaScript, and it's like super optimizable.
Gotcha. And then from there, the next step was to get to WebAssembly, right?
Yeah. And it was kind of the idea, like, I mean, we see people doing this in JavaScript all the time today. There was a really amazing volley of blog posts between Nick Fitzgerald and mrelif on Twitter that focused on this, like, WebAssembly, do you really need it? And it kind of, Nick had recently just posted this blog post about rewriting the source map implementation for Firefox in Rust. And it was Rust compiled into WebAssembly. there was awesome performance improvements, also a lot of that predictability stuff I was talking about before. But then there was a post by Ralph that said you might not need Rust and WebAssembly, which is playing off of the internet meme from, I guess it's like old now, but the you might not need jQuery meme.
Yeah.
But in his post, he's like, hey, you can write JavaScript that's super performant. And the answer is like, you totally can. In fact, the fact that you can write JavaScript that is super performant kind of almost led us to this WebAssembly thing
Right.
with wasm-js, right? Nick kind of followed up and was like, I mean, I have tons of friends on the V8 team. Like V8 is super cool. SpiderMonkey 2, they're doing all sorts of cool optimizations to your JavaScript. That being said, as someone who has also been an engineer on a team working on a code base that is old, the JavaScript that you have to write sometimes to get it to be super performant is pretty difficult to decipher. It's a little intractable and is kind of a maintenance thing. And so Nick's post was speed without wizardry, which is you can just write idiomatic Rust and it compiles and your whole team can just know Rust and doesn't have to know like a ton of V8 internals.
Yeah, very nice. Very nice. So I want to dive now into the big thing I was really hoping to cover on this podcast. As you know, I chair several of the QCon conferences, and I'll continue to do those. But as we were talking about before the call, I've recently joined a company called Section. Section is a startup that builds a developer-focused platform that brings containerized workloads to the edge using Kubernetes. You've recently left working with Mozilla to join Cloudflare. One of the things Cloudflare recently announced, and the thing that you've joined to work on, I believe, is Cloudflare Workers. And Cloudflare Workers is sort of all about bringing a serverless compute using V8 isolates to kind of edge workloads. So what I really wanted to get into is a bit about these edge workloads and talk a bit about how you see WASM and Wasi, which we haven't talked too much about, really affecting the space of edge workloads and what's going to be really done at the edge in the upcoming near future. I guess to start, I think of Cloudflare as a CDN, but that's probably much too narrow to really kind of label them as. So let's sort of start off talking about Cloudflare, what they're all about, and maybe what Cloudflare workers are beyond what I just described.
Oh yes, yeah. So I'm still new here, but I'm not so new that I don't know that calling Cloudflare a CDN company is a big no-no. I was like, that's on my like little sheet. Like, don't say CDN company. That being said, Cloudflare does have a CDN. Fundamentally, at the heart of it, Cloudflare is a hardware company. They have servers, metals all over the world. That's how they're able to pull off this CDN stuff. They can cache everything close to you. The whole goal is to destroy latency, right? It turns out that the internet is a physical thing and that sending information from something like New York City to Australia does actually take time. And you can make actual performance improvements by sending people in Australia data that is from Australia instead of having to travel all the way around the world.
The whole speed of light thing, right?
Yeah, that whole speed of light thing. But I love this idea of kind of bringing it back to like it really being like a physical thing. But Cloudflare also offers, I mean, it's kind of like everything that you would have found in like an old school server box, but instead of as hardware, they're giving it to you as a service.
Okay.
So we've got like some cool DDoS stuff. That would be the one thing I would like evangelize, especially since at working at NPM dealing with DDoS shenanigans, like it would have been great if we were on Cloudflare.
So like being able to stop like denial of service at the edge rather than getting back to origins, things like that.
Yeah, absolutely. And because we have this like huge physical network and are orchestrating so much of the internet's traffic, I think the number's like 10% of all requests on the internet go through Cloudflare's network. We can be smart about what type of traffic actually ends up hitting you. And we have great ways of like learning from that data. Yeah. And so we're really well positioned to take care of that type of stuff.
Very nice. So I mentioned that last year sometime Cloudflare introduced Cloudflare Workers. What is Cloudflare Workers first?
Yes, I am specifically working on the workers team. And much like everything in computer science and everything, naming is such a huge problem because workers are a very overloaded term. We got service workers, we got web workers, now we've got Cloudflare workers. And I'm not allowed to say edge workers for trademark reasons, apparently. Not ours. But fundamentally, what you can understand is for a long time, we've been writing code, on the server, like a server side application, or we've been writing code for the browser in like a client side application. And what workers says is, hey, like, why don't you write code somewhere else, somewhere other than the server or the client? Like, you can now take code that you would likely write in a browser, like a browser style JavaScript, except you can run it on a server, but that server can be distributed to 180 places all over the world all at once. So anybody who makes a request is going to be able to retrieve it just from somewhere right near them.
So what you just said sounds a lot like serverless architecture.
Yes. The workers product is definitely a serverless architecture. The difference being that your application, instead of living on someone's server somewhere, that server is immediately, like distributed across the world. So it has a server like serverless does, except it has like 200 of them and not
Within 10 milliseconds of an end user.
right. Exactly.
So, and then Cloudflare Workers uses Chrome V8, right?
Yes. So the architectural choice that we made for workers is using something called a V8 isolate. It's, exactly what's powering Google Chrome. It's what's powering Node. And we're able to run multiple programs on that architecture. And the nicest thing about that architecture is it allows you to write JavaScript and now WebAssembly. I mean, you get that for free.
Very nice segue. But before we connect the dots with Cloudflare Workers and WASM, I wanted to ask about security and safety with running different JavaScript workloads together like that. Are they isolate? How do you isolate them, for example?
Yeah. So everything is getting its own process. There's process isolation. And so the biggest safety concern that people often bring up when we're talking about Cloudflare workers is Spectre, which is a fun bug that we can jump into if you want. But otherwise, the real thing to say about security on workers is you have been using this security model on the internet for an incredibly long time.
Sure.
And the same way that you might visit, a shady website on the internet, maybe you'll pop open a private window for that one.
Yeah.
It's really similar to what we're doing here. Your browser is loading all sorts of questionable JavaScript probably all the time, unless you have JavaScript turned off, which I know some people do, but most don't. And it's keeping those things sandboxed for you so that things aren't leaking. And it's been doing that like incredibly successfully for a very long time. On top of that, we have turned off several parts of V8. So there's no concurrency. We don't let you have any timers. There's a couple other things also turned off just to be like extra sure. And a lot of that has to do with trying to mitigate some of the Spectre stuff. But one of the nice things also, like in picking a runtime, V8 feels like a good choice because one, V8's not going anywhere for a really long time. And two, there's a really great security program for V8. Got pretty fantastic bug bounties. People are hammering on it all the time. And of course, that doesn't mean that we should just rely on V8 to take care of security. We definitely have our own security teams doing all sorts of fuzzing and pen tests, but largely it's a technology that's being used, and we can anticipate, that it will continue to be maintained, and people will be paying attention to those types of things. Researchers are actively interested in looking at this because of how many people use it across all the different platforms that are leveraging it.
Right, totally. So what are some of the use cases you're seeing people implement with Cloudflare Workers?
Yeah, totally. Interestingly enough, like you say, Cloudflare, CDN company, originally, and one of the most positive use cases of workers is people using it to configure their CDN. And so it's kind of cool, though, that you can configure your CDN writing JavaScript. With it being the most popular language in the world, getting a JavaScript developer is probably simpler than some other languages that you might end up having to use. And so just being able to write it like JavaScript has been great. So people have been like, off stuff, or like, oh, I want you to, route all the traffic that has the.
I was going to say shaping traffic and I
Yeah.
don't know, localization and things like that.
Yeah, I mean, we've also seen a couple of really interesting things, and I'll talk about it in the abstract, but there's definitely like a set of companies that like often, like maybe say you're doing like A/B testing or something. And so you want to say like, hey, like show person A this version of the website, show person B this version of the website. And in order to do that, you've got some JavaScript in your site that completely blocks rendering, right? Until it knows what site to render. That makes sense, right? Except if you're trying to do user experience testing and the user stares at a blank page for a really long time, you might be biasing your results, right? So workers is, you can think of workers as like a cache for computation, which is to say, I want you to do this thinking, but I need you to do the thinking really close to where the person who needs the result is going to be. And that way, you don't have all of that latency. You can make that decision and that choice really quickly, do some rendering really close to that person, and just eliminate the latency involved in like doing that work.
Totally makes sense. Okay, so we've set the stage. Now let's bring this all together. Your background is with NPM, with JavaScript, with WASM. You've built tooling around Rust for WASM. And now you've joined Cloudflare, and Cloudflare offers these Cloudflare workers and the ability to run JavaScript at the application edge. So what does all this mean now for running WASM workloads at the edge?
Yes, I'm very excited. I think there's a lot of very interesting futures. All of them, of course, being futures. So I guess before I start talking about future stuff, I should make it incredibly clear. You can run WebAssembly on Cloudflare's edge today. It works.
Nice.
For anybody who's aware of my work, the first thing I will do to criticize us is say the developer experience is not there. WebAssembly is brand new. We've been building out tons of tools. I just released a tool in its early stages that'll be a CLI tool for building out WebAssembly workers called Wrangler, because I just moved to Texas and I'm trying to be extremely on brand.
Very nice. I'm from San Antonio, so we appreciate that.
Yeah, well, now I've got Ferris the crab in a cowboy hat. So
Very nice.
for those who don't know, Ferris, the mascot of
Yeah,
Rust.
very nice. So what is it? So when you say you can deploy WASM today on Cloudflare workers, what does that look like? I mean, you're writing a JavaScript function that you can deploy out to all these 190 pops or whatever it is that Cloudflare. What does it look like to actually deploy WASM out to those Cloudflare workers?
Yeah, so right now, you're totally right. Like what a worker looks like is this JavaScript function. But workers can have resources. You can, use npm packages, and so that WebAssembly is going to be a type of resource that you could use. And so, in your worker, you can instantiate that WebAssembly, and then for all of those request handlers that you're writing up, you can leverage that WebAssembly at any point. So say you have like the demo that I made for releasing Wrangler was somebody send post big old string, it's got some markdown in it, and then you want to parse that markdown and send back that HTML. What I can do in my handler is I can just, I've instantiated my WebAssembly and I can just call my WebAssembly function and it's going to do all of that work right there.
So that means is being able to bring like that a full application experience literally down to the edge.
Yep, exactly. Right now, like many serverless platforms, we're focused really on like that single request handler and you map it to a route, etc. But I have my eye on, especially with this kind of like Rust WASM feature, like you're saying write a full application on the edge. But the way you deploy that right now is a little weird.
Yeah.
Like you kind of have to deploy it as individual routes, right? You shouldn't have to do that. You should literally be able to take something that you were going to like stick on like a Heroku or, something like that and just say, no, like put it on the edge for me.
And these are the routes that it should handle, and this is how it should react when you hit those routes.
Right. Yeah. Like what if it could just like understand routes like the way you would declare routes in like an Express application?
Totally.
And so in that sense, once we get to that future, I think there's a spot for running pure WebAssembly where you don't have to like have that JavaScript route handler.
Yeah, which could be amazing. There's also something that I've read a little bit about lately called Wasi that I'm not sure that I completely understand, but I know that it has some incredible ability to create even more disruption here at the edge. Can you talk a bit about what Wasi is and why it could potentially be so disruptive here?
Yeah, absolutely. So WASI, WebAssembly System Interface, just to get the acronym out of the way. So WASI is a standardized system interface for running WebAssembly in places that are outside of the web. And so this is really exciting for me just to kind of start because like I've been working on WebAssembly and I've been going to conferences like QCon and saying like, my happy future is the future where WebAssembly, like we have WebAssembly OS,
Yeah,
right?
totally.
And people are like, that's bonkers, Ashley. And I'm like, just you wait. And so this is one more step in that direction. And so what it's doing is it's standardizing the interface for WebAssembly to talk to whatever is going to be kind of below it. So right now, people who have been writing WebAssembly have kind of assumed that it's going to be running in the browser. And so you can assume things about something living in a browser. However, sometimes we want to run WebAssembly somewhere else, but it's really hard to make assumptions about what all of those other places could be. And so what WASI does is it establishes this interface so that if you wanted to reach beyond, to below, similar to like when WebAssembly reaches into the browser, you've got all those web APIs there. What if I want to be able to access the file system, right? WASI says, hey, here's like a standard interface for how you could go about doing it.
So give me some context. What do you see as or what are some of the use cases for WASI that you're seeing?
One of the biggest ones that happened, obviously immediately after WASI was announced, was Fastly released a new runtime for their Edge called Lucet. And so that's like a pure WebAssembly runtime, and it's built on top of WASI. And so being a runtime that's built on top of WASI means that it's going to have some of the system level implementations that you'd want, and that the WebAssembly can take advantage of that. So, again, file systems. I don't know if Lucet has specifically implemented these, but I would assume, I haven't dug into their code. But there's also stuff like sockets, UDP, those kind of like lower level protocols that you might want the WebAssembly to be able to handle directly instead of having to do via a web API.
I got you. So the difference is that web API bit between what Cloudflare Workers and Fastly's Lucet is. One is like a runtime engine that actually runs WASM, and the other is a library, so to speak, that you're calling from JavaScript. Is that accurate?
Yeah, I think that makes a fair amount of sense. Like in a universe where there is a WebAssembly runtime, like WebAssembly is just a binary, right? Like you run it the way like you run an exe file on Windows.
Of course, makes total sense.
Yeah, so one of the reasons, like, I'm super excited about WASI, and I think there's a fair number of implications for what we can do in Cloudflare Workers, particularly dealing with traffic that's not HTTP traffic. But because we opted with V8, like, we get JavaScript and WebAssembly out of the box, and we like that JavaScript bit. Like, I will sit here and tell you on Rust and WebAssembly forever, but JavaScript's a really good language.
Sure.
And I'm sure the internet will come at me for saying that. But like, a lot of people write it. It's a thing that teams can maintain very well. And so being able to write JavaScript alongside the WebAssembly, I think is
Totally
good. And as I kind of was hedging before, like, there is a future where WebAssembly will absolutely be like the most performant choice for nearly every option, but that future doesn't exist right now.
Yeah.
Whether or not there is a performance benefit to writing it exclusively in WebAssembly is kind of yet to be seen. And so for a lot of like tasks, running through like a multiple compilation step process, if maybe all you want to do is customize your CDN, JavaScript's great for that. Why throw the baby out with the bathwater, So we've got both.
It's the thing that you can just expect that like everybody has, you're able to deploy it. It's what is the right use case for what you're trying to do. You don't have to, there's not one size fits all to every solution. So it makes total sense to me.
Yeah. And I mean, there's a really great ecosystem of developer tools and libraries as well. I mean, I'm literally trying to write all of the developer tools for WebAssembly now. No, there's a huge team of people working on that, and I'm sure we're going to see more develop soon. WebAssembly is for the early adopters right now.
Early adopters, but there's definitely some success stories out there of people using WebAssembly today, right?
Are you familiar with Zoom?
Yeah, of course.
Yeah, I freaking love Zoom, especially
Yeah,
because Zoom has an Instagram filter for your face. So if you wake up in the morning and you like don't look great, and you have to go on a work call, you can use Zoom's Instagram. Makes you look nice.
Are you kidding me?
No, I'm not kidding. It's like literally the best. This is not a paid endorsement.
That's awesome.
Zoom has a web client and it's written in WebAssembly. That was the point of the story.
I have seen the Zoom client, but I didn't dig into it. So that's written in WebAssembly.
Yep. Not Rust WebAssembly. I believe it's some script in toolchain, but yeah, WebAssembly.
One of the things I think is super important when you talk about adopting or discussing adopting new tech is, or some of the gotcha, some of the things that you might not normally expect when you're diving into a new language or new paradigm. One of the challenges that I've heard people talk about when talking about WASM, and you touched on this a little bit earlier, are kind of the limited number of types. Can you talk a bit more about the reality of types today with WASM, maybe where this is going?
Yeah, absolutely. So WebAssembly only understands there's like four kinds of numbers, and they're integers. And yeah, as I said, nerd glasses on, you can express any program in these numbers,
Yep.
but it's just really unpleasant. And there definitely are some arguments for growing that kind of like type system of WebAssembly.
Yeah.
But with any type of tool like this, it's like, do you want to solve it in the core product or do you want to solve it in the tools? And I'm like, it's WebAssembly. We're already talking about compilation. We have the magic of compilers. And so I think I'm personally kind of on the side, and who knows, this is a strong opinion, extremely loosely held, on the side of maybe not expanding the number of primitives in WebAssembly
Oh,
and
wow.
just, building out good tooling that is going to help handle a lot of this for you.
Yeah, because at the basic level, as long as the developer doesn't have to deal with those lower level primitives, then what does it matter?
Right. And I
Yeah.
figure if we're already using compilers, I mean, if you look at the Rust WebAssembly toolchain, we fundamentally have two compilation steps. One step that's just like take my source code, put it into WebAssembly, and then the next one that says, "Oh, okay, now I'm gonna like generate JavaScript for you. I'm gonna look at all your Rust type signatures and all of this, and get you to a place where you can talk to this just as if it was JavaScript."
Very cool.
And there's some fascinating work going on inside there. If you ever want to like learn a little bit more about WebAssembly, JavaScript, Rust, like take a look at like writing those bindings is just very, very interesting.
No, I bet. I bet. So 2017, March 2017, the MVP was implemented that kind of proved WebAssembly. Then I think in like early part of 2018, there was a WebAssembly working group that published 3 drafts: core specification, the JavaScript interface, web API. Where have we got to in the last year? Where are we today with WASM and Wasi?
Where we are with WASM, where we are with WASI, and where we're going are all kind of tied with this idea of what problems we want to solve with WebAssembly and where we want to solve them. And so WASI obviously is talking about like, hey, we take WebAssembly out of the web. How is it going to start interacting with that host? And it's kind of starting to define that system interface. Meanwhile, if we look at WebAssembly back in the web, there's still a fair number of things that we need to build out to get WebAssembly really tackling the things we want, which are really like, heavyweight native applications to be able to be in the web. And so I would be very remiss if I didn't just first say that the number one thing you should do to answer this question is read a fantastic Mozilla Hacks blog post that is illustrated and written by the fantastic Lynn Clark. She literally wrote a skill tree for what does WASM need to learn in the next couple of years.
Very cool.
And so it's extremely well done. And so I'll probably touch on like just a subset of the things she talks about in there, but go check that out because it is very rad.
Yeah, Lynn's totally came up a couple times in trying to get her out to QCon, but we've never quite had her out there. So I have to check it out. So what does WASM need to learn in the next couple of years? Cool.
Yeah, absolutely. So when we talk about what WASM knows about where it is running, people familiar, which is probably like a very small number, I guess, people familiar with what's going on in the WebAssembly community group right now will know this as what is called the WebAssembly host bindings proposal. Um, and so the host bindings proposal is kind of talking about this idea that like right now WebAssembly kind of relies on a bunch of support from JavaScript and web APIs to actually be useful on the web.
Yeah.
So like, people will be like DOM access and that type of thing. Like we're able in a Rust WASM toolchain story to like allow you to access the DOM because we are doing a fair amount of heavy lifting with the JavaScript and the web APIs. But what if WebAssembly kind of understood that stuff natively? And so like the goals there is like it should be able to like WebAssembly modules should be able to create and manipulate JavaScript and DOM objects. And all of those kind of host calls should be well optimized. And then I know that recently, and again, this happened like about a week ago, and I'm not able to find the notes right now. But one of the ways that we did this in the Rust WASM toolchain to be able to get Rust to interact with all of the web and JavaScript APIs was to use WebIDL. So I believe that the host bindings proposal's name has now changed to something that sounds like WebIDL, but I don't remember what. And that's fine. You could just say that. Like it just recently changed. We were talking about this in our Rust-Wasm meeting. So I think they're going to be using some of that to try and talk about basically just how WebAssembly can more natively understand like the browser and talk to it. Think of it as WASI, but for the browser.
So before we go, I think I don't want to say that you have a big announcement, but don't you have a big announcement coming up at like JSConf in the next few weeks?
Yes, so early June, I'll be traveling out to my favorite city in the world, Berlin, and I'm gonna have some exciting things to share about the Edge and how I think it's gonna change the internet.
Very cool. So if you want to learn more about how the Edge is changing the internet, be sure to check out Ashley at JSConf EU. Ashley, thanks again for joining us on the podcast.
Oh yeah, thanks so much for having me.